So let's find for the equation of the parabola with vertex at the origin, axis on the y-axis, and passing through the point -4, 4, and let's sketch the graph. Okay, so first thing to do is to have or know the details of our graph and equation. So we are finding for the equation, so therefore we must know the vertex, the origin, the focus, and our a, of course. Now first, let us grab the problem. So according to the problem, the axis of symmetry or the axis is at our y-axis. Okay, so therefore let's have this y-axis, and then let's have my x-axis. Okay, so we have our y-axis and x-axis. Now we have our vertex at origin. So the vertex is here. Now next we have, this is our axis for parabola. Now the next thing to do is another detail wherein it is passing through -4 and 4. So therefore we have 1, 2, 3, 4. 1, 2, 3, 4. We have -4 and 4. Okay. Now we have already our point, and of course since our parabola will pass through that point, we may consider that our parabola is opening upward. Okay. Now since it is at -4, 4 and our vertex is at 0, 0, we may also say that by its reflection property, the parabola is also or has also at point 4, 4. Okay, it would reflect, right? Because that is a conic section. Now, if you are dealing with this conic section, let's go back to our standard equations that I have derived. Okay, so it is opening upward. So therefore, we may say that we have a formula x squared, which is equal to positive 4ay. Right? This is for a parabola opening upward. Now, one thing to consider here is we should know what is our a. Okay, take note that our a is the length of focus to the vertex. Let's say let's have a value a here, unknown a. You are in this length from 0, 0 will be our 0a, and it is also the length of the focus of the vertex, and our a is also the length of our directrix. Not length, or the distance, of course. Distance. So maybe the best term is distance. So a is also equal to the directrix, or directrix distance, or distance of directrix. Distance of directrix to the vertex. So therefore we have our distance here. Let's call it as our A. Since it is below, or should be lower than our vertex, we may call this as our, from the point 0, negative A. Take note that this is our directrix. Okay, and from here, the next thing to do is, of course, to find for our A. Okay, now there are two solutions that I will show you in finding for our A. The first solution is to know solution 1. The first solution is to know the opening. Know the opening. So this is for our step number 1. Why should we know about the opening? In order to use the standard equation of the parabola at 0, 0. So from here it's opening upward. If you have x squared minus equals negative 4ay, it is opening downward. If you have y squared is equal to 4ax, it is opening to the right. If you have y squared is equal to negative 4ax, it's opening to the left. But if your vertex is not at 0, 0, therefore you would just adjust each of this equation by simply subtracting our x minus h square at x, and we have negative 4a multiplied by y minus k at y. Same is true with the other equation. Now, since our equation is opening upward, we may consider this x squared is equal to 4ay and use the point negative 4 and 4 to find for a. So our second step, so after knowing this, the opening, so since we know the opening, we may consider using our solution x squared is equal to 4ay. After knowing the opening, next step is to substitute values of x and y, because our x and y are points within our parabola, and in this we have 2 points, which is our negative 4 and 4. So let's say at point negative 4, 4. So this is our x and this is our y. Okay, so from that, if you have your calculator with you, we have, let's substitute our x squared for and our y. So we have find a. We will substitute our x here and our y here. Okay, so we'll have negative 4 square, which is equal to 4 multiplied by a multiplied by 4. So we'll have 16 is equal to 16a, cancelling out your 16 because 16 divided by 16 is 1. We may say that a is equal to 1. Okay, now since we have a is equal to 1, therefore we can actually find for our equation, right? We would just substitute a to this graph. So therefore the equation, or the standard equation of parabola is simply equal to x squared, which is equal to 4 multiplied by 1 multiplied by y. So x squared is equal to 4y. Okay, next, the another solution to find for y is, let's say, solution 2. Okay, solution 2 is to derive our equation. From this, we all know that our focus, let's say this is our focus, another color, let's have a focus, and let this be a distance. This is our P, okay? So P, F. Let this be a distance, PF. And next is our directrix. We have our directrix here. This is a line, okay? So therefore, this line is equal to y. Since this is at y, is equal to negative a. The equation of this y without our a is y plus a equals 0. So from here, I will have a point, okay? From this, I will draw a perpendicular line to our directrix, okay? You must remember, this should be always perpendicular. Let that be a perpendicular line. And we may call this as our line, PD. So if you listen carefully or watch carefully our video presentations, our video discussion, I always emphasize that our line PD is equal to our PF. That is a property of our parabola wherein our fixed point and fixed line has equal distance to any point within our parabola. That's the reason why our A from vertex to focus is equal to our A from directrix to vertex. Okay? Since PD is equal to PF, the next thing to do is finding for our PF and PD. But what is our PF? PD I should say. Now, let's take a look for the point of our PD. So we have negative 4, 4. So therefore, we can understand this as our negative 4, negative A. Okay? So we have a point negative 4, negative A, and negative 4, 4. Now, let's have our PD. Our line PD is equal to, let's use our distance formula. We have x sub 1 minus x sub 2 minus x sub 1 all over y sub 2 minus y sub 1. So any of this point can be our y sub 2 and y point 1, point 2. So I will just consider my PD, okay? So PD. So I will just consider my D as my line 2 and my P as my point 2 and my P as my point 1. Okay? So from here I will have negative 4 minus negative 4 square plus we have our PD. We have negative A minus 4 square. Okay? Next is my PF. So my PF is simply equal to, so PF will be from square root of, okay, PF. So for my point P to my F, okay? Okay. So we have my PF, line PF, okay? So we have F which is equal to 0 minus negative 4 square plus we have F, so A minus 4 square. Next is, since PD is equal to PF, now let's have PD which is equal to, so I will just simplify my PD. So this is equal to 0. And here I will have square root of negative 1 multiplied by A plus 4. Take note that these two are both squared. So negative 1 squared will be, this will be equal to A plus 4 square. Notice that I will not remove that square root immediately because we will have value later on that the square root will be discarded. So we have our PD which is equal to A plus 4 square, which is equal to square root of negative 4 multiplied by negative 1 is 4 squared. Will have 16 plus a minus 4 square. If we square both sides, we'll have a plus 4 square, which is equal to a minus 4 square plus 16. So if you would square both sides, we will have a square plus 8x plus 16, which is equal to our a square minus 8x plus 16 plus 16. You would notice that one of the 16 will be equal to 0 and our 8 square will be equal to 0, and I will transpose my 8x. I will have 16x. 16x. Wait, this is 16a. Sorry, 16a. This must be 16a. Okay. So the variable that we have used is a. Okay, which is equal to 16. Therefore, our a will be equal to 1. Okay, so our a will be equal to 1. Now from this we have found our a, which is equal to 1. Therefore we may say that using the formula again, x squared is equal to 4ay. We'll have x squared, which is equal to 4ay, but our a is equal to 1. Therefore our equation will be equal to x squared, which is equal to 4y. Okay, which is similar to our answer. Okay, those are two things, or those are two solutions in finding our a.